Hello, everyone. My computer. Today we're going to be talking about AP Stats, um, sampling methods, and just gathering data. So in stats, gathering data and obviously analyzing it is kind of what it all is. So you have to make sure the data that you're gathering is actually good data, not biased or influenced. And today I'm going to kind of show you the set, just kind of how to gather data, how to gather data effectively, what to watch out for, and all stuff like that. So first, we're going to talk about the types of sampling methods that we have, and the first one we have is an SRS, or a simple random. Wait, I'm sorry, simple random sample. So what this basically is just a bunch of you're just picking randomly. So some example of that would be, let's say we had some population. Let's say we had a class roster, right? Let's say we had a class roster of like 10 people, 4, 5, 6, 7, 8, with like some names, right? A random sample would be assigning a number to each one of these, like I have here, and just doing a random number generator, and that would pick randomly. So that's how that works. Um, a stratified random sampling is basically just dividing the population into categories of some external variable, and doing an SRS from the strata or the categories that you're dividing it to. So an example of this would be dividing people by, let's say, political preference to see like what kind of changes between them, what they call the political parties. So you could divide people by Republican, uh, Democratic, and there's Independent. There's some others I'm leaving out right now. These are just the main three. And one thing to do is when you divide by these three and then you do your SRS, one thing you want to do is make sure you are picking proportionally. So let's say there was more Republicans than Democrats and more Democrats than Independents. You would want how many you're picking from each strata to represent that. So let's say there was like 40 Republicans in our sample, maybe like 30 Democrats and like 22 Independents. The most to get a like the most you would want to pick from each of these categories is proportional. So you would want to pick the most from Republicans, the second most from Democrats, and then the least from Independents, because that'll give you the closest similarities to the distribution that we have. But yeah, so that's stratified random sampling. Now let's talk about a cluster sample. A cluster sample is basically when you divide the population into clusters based off location, and then you randomly select clusters and use all the individuals in the cluster. And this is basically used when doing an SRS is kind of too complicated because maybe it's not as accessible and not as practical. So an example would be that would be, let's say, a factory manager wanting to see how like his boxes of chips are doing. So like you've seen those boxes of chips where it's like a 24 pack of chips, 24 packs, right? And what those factories probably make a lot of these boxes a day, right? So let's say there's like 24, 24, right? And this will kind of be maybe a factory manager wanting to see like how the production is doing. Maybe is there enough chips in the bag and all. So what that would be is maybe randomly selecting three boxes or clusters from the total production, and then just checking to see every single bag in there. So let's say we selected this one out of the three. We would look at all 24 bags in there, and we would generalize that to these other two, and that's the assumption. And I'll tell you what the little purple asterisk is in a little bit after we kind of get through all these sampling methods. Now we have a systematic sample. So that is just randomly selecting some number of individuals. So that's kind of like you were to stay in one place or just talk to people passing by you kind of thing. So let's say you wanted to survey people going into the mall. Well, obviously you don't want to talk to every single person going to the mall. You can't. Like one person cannot simply just talk to every single person going to the mall. So it could maybe be you positioned at one place in the mall and talking to maybe every 10 people that walk in and asking them a question. So you would sample the first person, then you would let the second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th go, and then get the 11th. So that's every 10. That's kind of what that is. Um, Now let's talk about voluntary sampling. That's voluntary responses are basically when people volunteer for surveys. So when you see those ads online for, oh, like volunteers necessary, that's what that is. That's a voluntary response survey. That's all that is. Or an online poll, something like that. And it's pretty similar to a convenience sample right here, which is just using individuals that are readily available. So an example of that could be, let's say if I wanted to poll you guys and ask how do you guys like my channel, I could just basically ask you guys that, and you guys could tell me, and that's kind of a convenience sample. I'm asking people who are conveniently already watching my videos, kind of stuff like that. I don't have to go out of my way. That's kind of just like, yeah, it's just easy for me to do, basically. That's what that is. So, as you can see, this purple asterisk is basically bias can be introduced into your data. And the reason that is, well, we'll cover the different types of bias, but the reason that is because all of these are usually either you're not representing a certain group, or you're ignoring some people who may not respond. So let's say for your voluntary response, you could be completely ignoring a group of people that just don't want to respond or take the time to do your online poll, something like that. That's not your fault at all. Like, that's the difficulty of stats, is trying to make sure like you can get this good data, but in the end there's not a whole lot you can do, but I'm going to tell you what you can do. That's what this video is about. um so yeah, let's go over the types of biases, and then we'll come back and I think to have a better understanding. So there's three types: undercoverage, non-response, and response. So let's talk about undercoverage bias. That is basically a portion of the population is not represented or underrepresented. So let's go back to our political party example of our Republicans, our Democrats, and our independents. I know the handwriting is bad, but that's not the point of this. So we have like 40 Republicans, back to our example, 30 Democrats, 22 independents, right? So that could basically mean, let's say, in our sample, we just don't talk. We just don't talk to independents at all. We completely exclude them from our sample, and we exclude their opinion. So that's what undercoverage could be: completely just not representing them at all. Or it could be, let's say we were representing them, but not representing them proportionally to the amount that we were representing the other two. So let's say we want to talk to a fifth of the people in each strata. Let's say that was the goal. So you would talk to a fifth of 40 is 8. So you would talk to 8 people here. You would talk to 6 people here. And let's say instead of talking to a fifth here, we talk to maybe like a seventh. That could be underrepresenting them. That's what that is. Non-response bias is when people do not respond to your survey, and so those people's opinions are kind of left out. This mainly happens in online polls or phone calls, stuff like that. When you are calling them, maybe they don't respond, something like that, or online surveys when people can just easily just tap away, some stuff like that. So that kind of leads to, I guess, another form of undercoverage, because of the fact that people are not responding. So you kind of like people's beliefs are being left out. And the last kind is response bias. So this is when people's answers don't exactly reflect their true beliefs. So this is usually going to happen around touchy subjects such as political subjects and stuff, like things like that, laws, like things like that, and especially when things aren't anonymous, because we all know that it's easier to say things behind, like, when you have anonymity than if it is you directly. So let's go back up, and now that we know what that is, we can kind of get a better example. So convenience could be non-response bias or undercoverage, because you're really leaving people out. You could be leaving people out. Voluntary is complete, could be response bias, and all three basically. Response bias people could, what's it called, just not reflect their true beliefs. Or people, what another part of response bias is also when people believe strongly. So people who are on the fence about something or don't really care will not even respond. So something like that would be, let's say you were really passionate about something like physics. Let's say, okay, and let's say I asked some question about physics. You obviously, who feel strong about it, are gonna respond, right? But maybe someone who's pretty on the fence, like, like maybe let's say your brother, if you have one, right? Or maybe your friend who is kind of who like, like physics is cool, but like I don't really like care. Like maybe they won't even take the time to respond, right? And then let's say there's someone like, oh, like oh, I hate physics, I have to respond to this, right? Something like that. It's when people's like only when like extremists kind of answer. So that's kind of what happens with voluntary responses and convenience samples also. Um, Cluster samples is just under coverage because you could be leaving out populations, you could be leaving out some people like people's beliefs. I know in the chip example that wasn't there, but if you kind of think about it, this we had 3 boxes of 24 bags. We were kind of leaving out everything that was in these just because of the fact that we picked this cluster, the top one. So that's kind of where that is coming from. Like we are completely not representing, completely excluding the 48 bags in this box and this box. So that's kind of where that's coming from. So types of bias, experimental treatments specifically. So, I'm sorry, are we right here? Yeah. No, I'm sorry. Experiments. I didn't see my 2 dots here. My bad. So these are treatments specifically. So treatments specifically imposed on people to observe their responses. So something like this could be, let's say, how does TV affect someone? How does like so that maybe they would show one group of people an hour of TV and the next group would be like 2 hours of TV. Maybe say like how does it affect like their like cognitive ability and see maybe like give them a performance task after and see like how they perform. Something like that. So some key terms to know for these are levels, which are specific amounts types of something. So let's say how much TV that you would actually like show them. Let's say one level could be an hour of TV, another level could be 2 hours of TV, something like that. A treatment is the experimental condition given to individuals. So that's kind of written a little bit differently than you would expect. So let's say it was 1 hour of TV, but then it would also be, let's say, I'm sorry, give me 1 second. It could So it's kind of the treatments are when you're dividing by factors and levels. So usually this will happen when you're having more than one level. I'm sorry, I kind of messed up there. I have to look at my notes real quickly. So let's scrap that TV example and let's say we have an example of how supplements can affect you. So let's say you were taking a vitamin D supplement either 2 or 3 times a week, and then so let me write that down. VD sup 2 to 3 times a week, or let's say um, fish tablets, which also give you vitamin D. Let's say that would be 1 or 2 times a day. So your treatments would be uh, V2 for vitamins 2 and F1. You would have V3 F1. Sorry, this shouldn't be a comma right here. V3 F1. Um, V2 F2. I don't know why I put it in commas. V2 F2, and then V2 F. Oh, no, V3 F. 2. Sorry about that one, guys. So that's kind of, yeah, when you have more than 2 kind of levels, that's when these treatments are written like that. Um, Now to go into experimental units, that is who you are performing the experiment on. So on that TV example, I said humans with the fish with that vitamin D and fish supplement thing. Humans. Most nowadays experiments are done on mice and rats. So experimental units would be mice and rats there. So now let's talk about confounding versus common response. We'll kind of confounding variables and common response variables. So confounding is basically it's unknown if the response y is due to your factor of x or your factor of z. So let's say an example of that is a soccer coach is unhappy with how his team is performing and how his team is practicing. So let's say he has them run like 2 or 3 laps, run laps every practice. I'm sure every soccer coach has their kids do this either way, but let's say we like run laps or run more laps, kind of. But let's also say that these students are now going home and taking supplements, right? And then their performance increases. So performance is increasing. Let me rewrite this. But um, what that's actually saying is what's increasing it. Is it the running laps, or is it the supplements, or is it a bit of both? Like you won't know. So that's what confounding variables are. When you don't know what it's due to, you don't know like what the result is due to. Common responses is when X and Y have no relationship, but another factor Z, which you may not know about, relates them. So let's say we're going to talk about shoe size and reading ability, right? So shoe size and let's say literary level. Well, let's say it's found that shoe size goes up, so does literary level. Well, do you know what else goes up with shoe size and will increase literary level? That's usually age. So this is a third factor where shoe size and literary level most likely have no actual relation between the two, but it's age that is impacting these. So something like that. Uh, Now let's talk about making well-designed experiments and what they should entail. So each experiment should always entail a control group. So a group that gets no treatment. Let's say if you were going to determine how a drug um, can impact diseases, you would have one group with the disease that does not get any medicine, maybe another group that gets some, and then another group that gets more, some stuff like that. Um, Blinding, the subjects wouldn't know what treatment they're getting. This is usually with a placebo. So going back to that disease that I said, maybe one group would get a placebo pill, so not the actual medicine, but think they are. One group could get the actual medicine, and one group would get nothing, a control group. So then at the end, you would compare the results of each group to the control group to see, like, oh, like how's the experiment doing? How's the drug doing? Is that actually helping, or is it just a placebo? Double blinding is when the subjects and those being tested on don't know what they're getting. So, like, I'm sorry, the subjects and the test admin don't know who's getting what. So, I mean, the test admin may not know who's actually getting the placebo and who's getting the real, and obviously the subjects don't know that either. So, that wouldn't really be done in our example of the disease. Let me try. But it's usually when if the test admin know what they're doing, maybe they can like introduce some bias. So stuff like that. And then a placebo is a fake treatment, which we went over. Blocking, which is separating the experimental units into groups, and so that each people in the things in each group are fairly similar. Randomization is just making sure you're randomly selecting from a population, making sure you're doing all that, because that's when you start doing hypothesis testing in the next unit, you are going to need to realize everything needs to be random. And then replication, maybe doing the same experiment like more than once, because that way you can see maybe let's say something happened in your first time running the experiment and that impacted your results, but you wouldn't know unless you run the experiment a second time. So that kind of like helps get your variability out of the way. Now, the last thing we're going to talk about is observational studies, and then that falls in two categories: retrospective and prospective. Retrospective is when the subjects are chosen and the past records are looked at. So let's say past medical records are looked at. So people maybe recovering from a surgery, they're looking at how they get better over the years. Obviously, you would use this when you wouldn't want to do an experiment. You wouldn't want to do surgery on someone if you didn't need to, if they didn't need it. You wouldn't do surgery on people just because you want to see an experiment. You would do it if they need it. So that's why you use a retrospective study, to see people who have gone to surgery and how they have like adapted. So, let's see. And then a prospective is basically when subjects are chosen and data is collected as time goes by. So that's something where, like, let's say you want to impact how smoking impacts people's health. You would pick a bunch of smokers, and then you would slowly like you would collect data over a long extended period of time and see how smoking is impacting their overall health. You wouldn't want to put experimental people, have them smoke and like ruin their bodies when people are kind of already doing it. I guess that's kind of a bad example, but let me kind of rephrase. So let's say it is seeing how playing an instrument can impact intelligence. So obviously, becoming good at an instrument does not take us some short amount of time, which is why a prospective study will be necessary. Because experiments are usually shorter amounts of times. These studies are usually longer, extended amounts of times. So obviously, you wouldn't become good at an instrument for a pretty long time, and also measuring intelligence isn't the easiest thing to do either. It's kind of very subjective. So that's kind of when a study would be used. So I hope this helped you guys kind of figure out and learn how to kind of collect data effectively and how this works. I hope this is helping. I'll see you guys in the next video.